Today's Friday, so what we're going to do today is we're going to do 304 to 309. So let's go ahead and get started. So we're actually talking about this time the conservation of energy is what our topic is about. So the law of conservation of energy, we've done this already, where nothing can be created nor destroyed. Remember, in an isolated system. Mechanical energy, we have a formula here. So the formula for mechanical energy is kinetic energy plus potential energy is our formula for that. And then our conservation of mechanical energy is kinetic energy 1 plus kinetic energy 2 equals kinetic energy final plus potential energy final. So the initials and the finals of kinetic and potential energy has to be equal based on the conservation of mass and energy. So here in our book, it actually gives us the scenarios of conservation of mechanical energy, and is basically showing you the gravitational potential energy and the kinetic energy and how it changes as a car is going over in a roller coaster. This is what you need to look at. You need to look at where gravitational potential energy is always the highest on the top, right? Because there's less kinetic energy until it starts going down. But when it goes down and it goes right here, see how the kinetic energy is so much more than the gravitational potential energy? Because there's no gravity here. Look, gravity's here, but there's no gravity there. And then for D, you're at the very top the roller coaster, and when you look at that, then your gravitational potential energy and your kinetic energy are the same. And then at the bottom again, of course, your kinetic energy is more and your gravitational potential energy has nothing. Also, it showed you on the example of somebody that's at a ski slope, and as they're at the top, gravitational potential energy is the most, kinetic energy has nothing until he starts going down, until he gets down to the very end. When it gets down to the end, the kinetic energy is the most, but the gravitational energy is the least. After that, they were giving us some problems. So I only chose 2 problems today, which that's the only 2 that you have to do if you're watching the video. So for number 16, it says a bike rider approaches a hill at a speed of 8.5 meters per second. The combined mass of the bike and the rider is 85 kilograms. Choose a suitable system. Find initial kinetic energy. To the system, the rider coasts up the hill. Assume friction is negotiable, and that the height of the bike comes to a rest. So based on that formula, you should use this formula here, which the kinetic energy initial is what we're looking for. You would do half times the mass times the volume squared. So in your calculator, the first thing you're going to do is make sure that you're in normal mode and in radian. So then you're going to do alpha y inner 1 over 2, because as you can tell, that's a fraction. Then you're going to times that by the mass, which is 85 kilograms. And then you're going to times that by the velocity, which is 8.5. We're going to make sure we have a bracket around that 8.5. And then you're going to square that at the end. And as you see, I get 3,070.625. You can also change it. That's the correct answer, but you also can change it in a scientific notation because it's a big number. Second answer, enter, and that is 3.7 times 10 to the third joules. As you can tell, since it's 0.7, you would round that 0 up to a 1, and that's where I get my 3.1 times 10 to the third joule. No external forces have the total energy is consumed, and then therefore the height will equal velocity squared divided by 2 times gravity. So we're going to put this formula in. As you can see, it's a fraction again. Alpha y inner to get our fraction. Open bracket 8.5, close bracket, and then square that. Go down and do 2 times 9.8. Close your bracket, move it over, and then you should get 3.68, which I changed it to 3.7. So let's look at number 18. It says a skier starts at rest at the top of 45-meter high hill, skis down a 30-degree incline into the valley, and continues up a hill at 40 meters high. the height of both the hills measured from the valley floor. Assume that the friction is negotiable and ignore the effect of the ski poles. So the first one it's asking us for is how fast is the skier moving to the bottom of the valley. So the first thing that I'm going to do is I am going to use this formula here, which is V equals the square root of 2 times gravity times height. So I have to do square root first. And if you remember to do square root, you look on your calculator and then this right here, that blue button. So a second where the x plus is, and that's the square root. Open bracket 2. Open bracket 9.8, which is gravity, and times the mass, which is 45. And then if you hit your enter key, you got 2.96 times 10 to the first. Since that is a 9, I would round that up to 3. And that's how I have 3.0 times 10 to the first. So the next question for B says the skier's speed at the top of the second hill. So we're trying to find out what it is on the top of the second hill. To be able to do that, we're looking for velocity 2. To be able to do that, we're going to do a square root again of 2 times gravity. But this time, we're not using the mass. We're actually doing the height of the initial minus the height of the final of the hill. So we're going to do our square root again, which is our second x squared, 2 open bracket 9.8, close bracket, and now we're going to take our hill initial, which is 45 meters, and we're going to subtract that by 40 meters because that's our final one. We're going to close our bracket, and then we're going to hit enter, and you should get 9.899, which I rounded up to 9.9 meters per second. And then for C says, does the angle of the hill affect your answer? And that is no, the angle has no impact at all. If the angle had an impact, then we would have to do a sine or a cosine based on that angle. We would also have to change our mode in our calculator to degrees. But since it doesn't affect it, based on the numbers that we have here, we can just keep it the same. So if you watch the video, you're only going to be required to do 16 and 18, and make sure you put your notes in here. Attach this. Since this is Friday, then it will be due on Sunday night. If you have any problems or if something needs to be turned in, please make sure that you stay on task with that. You have until the 15th of next month for me to turn your grades in. I will be contacting some of you if you are in a possibility of failing. So what we do is we will take quarter 3 and quarter 4. Quarter 3 will be 50%, quarter 4 will be 50%. You would take those two grades, add them together, divide by 2, and that would tell you what your grade would be for my class since you don't have an exam. I hope you have a safe weekend, and I will see you again on Monday.